Let's see how it works. A big fan at the front of the engine pulls air around the engine and sucks air into the core. We'll come back to that outside air in a moment. For now, let's follow the air in the core. It goes into a compressor, something like many household fans joined together. Each fan gets smaller and smaller as the blades squeeze the air into a tighter and tighter space, compressing the air like you would squeeze a balloon, until that squeezed air is mixed with jet fuel, a kind of super gasoline. In the combustor, that air and fuel mixture meets a flame and shoots out the back of the engine. The rush of hot air spins a turbine. The turbine is like a windmill that scoops up energy from the heated air and spins the shaft connected to the fan at the front of the engine. The excess hot air from the combustor blows out the back of the engine, producing thrust.
Because you know there are people out there, as crazy as it sounds, who question if the planes are really flying on fuel. They do question that.
I've looked at the nature of the way a turbine works. I think it is, like, it does loop back on itself. I think once they get them fired up, they actually have to put the brakes on to slow it down. It's like a feedback loop. It wants to go faster and faster and faster on its own. They actually apply brakes to stop it from running away from them. So it's like something that wants to go faster, but they have to hold it back. And they do fire them up and get them. Well, that's what the nature of a turbine is. Once it compresses that incoming air, it feeds back part of that air to feed an internal chamber that spins the so it's like looping back on itself apart from pushing the air through. So apparently you can fire one up, and if built correctly, they just run away with themselves. They don't need. It's an interesting concept. I don't know, like, it's hard without being able to treat one for myself.
Sorry to interrupt, but you're suggesting, like, that they still need fuel. You're saying that the turbine, once you get it started, will keep sucking more and more fuel so long as the fuel is there. But if the fuel ran out, the turbine would still stop, is what you're... Or are you saying that you actually think the turbines are, like, free energy, freewheeling already? Is that what you're saying?
I'm not sure if they... Like, I think the fuel's more got something to do with creating hot air and its expansion-contraction concept. But from what I know, there's all these tubes on the turbines that feed from compressed chambers back to non-compressed chambers. And if you know about harmonics and the way that works, it's possible that they create sort of buffers of air. And it's got to do with the precision engineering of the turbine that allows certain pressure pockets to exist and suck more air in. So I think, in a way, it's possible that they could suck stuff in. Maybe they do need fuel to create heat at some point, but I think the nature of the turbine, that is, it's just going to keep going faster and faster on its own unless you put resistance in it.
Sure, but we need to be clear here. Are you talking about the official story or what you think is actually happening? Because I'm not sure if
this is what I think is actually happening.
Ah, okay. I see.
Well, I don't know. I think I've seen somewhere that that's the way turbines work. The idea is that it's got all harmonics in the fan blades so that they resonate with each other in a way that allows them to gain efficiency and it's kind of hard to explain. But I get, like, from the same way sound waves work, you can align things in a certain phase. It would have to be to certain measurements and requirements that would allow it to, constantly accelerate to the point of destruction. Like, if you look at inside them, they are just very big, heavy steel or, whatever, extremely high quality metal, but they're very simple precision engineered fans. There's no lots of little confusing parts. It's quite a very beautifully polished, precision built fan blade, and there's lots of them all working in certain resonances. So, like,
I dig what you're saying.
Think of it like if you and I, if there's a big pipe, right, and I like suck in a bit of air into my mouth out of that pipe, air comes in the other end of that pipe, but I wasn't sucking the whole length of that pipe. I was just removing air from where my mouth is, and it has a knock-on effect all the way through that pipe. So I think resonances can be created in the fan blades that they actually feed themselves.
Well, I'm looking at a cross-section of a plane turbine as we speak, and it is fascinating because we see, when we look at a plane engine, say when we're boarding it, we can see, 20, 30, 40 blades at the front, right? But the cross-section shows that they've got all of these little, they're kind of like miniature blades. Like there's we can see one row of blades at the front. That's the big row. But in fact, according to these cross-section images, you've got a dozen, 2 dozen more rows behind it, smaller with smaller blades. It's just like a complete, like the whole engine is these blades. You know, do you see what I'm trying to say?
Yeah,
like
yes.
Goes the length of the case.
But the ratio of the gap in those blades, that the angle of those blades, like what do they call it on a helicopter? Like the collective, those kinds of things. They're all spaced at certain ratios, and those are just big brass, whatever, you know, I don't know what metal it is, but they're just big, heavy steel components that you would think would have a very long lifespan just doing that task day in, day out for years on end. There's no sort of, very high complex stuff in there.